So from question 7 onwards, we've got what we might consider slightly trickier Born-Haber cycles, just because they're not 1 plus 1 minus ions in the lattice. We've got some examples of group 2 ions in the lattice. Doesn't change the Born-Haber cycle that much, but there's a couple of wee pitfalls you can fall into, and it doesn't really change the style of the questions. A lot of them are still about just calculating the lattice enthalpy. So the first question talks about magnesium chloride. So obviously, just writing the formula first. Magnesium's in group 2, chlorine's in group 7. So we've got a magnesium 2 plus ion to worry about instead of just a 1 plus ion, and we've got 2 chloride ions to worry about as well with this. So they've given you nothing in the Born-Haber cycle apart from the boxes, so you have to fill in pretty much all the changes yourself. Now, one thing you might have missed out on, they also ask you to write the enthalpy values on the diagram, so not just the changes, they want actually numbers on the arrows as well. So starting point is always at the bottom, starting with the salt itself, and that's in the solid form. And then we put the last enthalpy change second of all. And then working around the other side of the cycle, we normally come from the enthalpy of formation, which is from the elements in their standard state. So magnesium as a solid, and we'll need chlorine as a gas. We'll need 1 whole mole of chlorine because we need 2 chloride ions. Then we'll atomize our magnesium, turn it into a gas. Then we'll do our first ionization energy of magnesium, get into an Mg plus ion. And always remember to put the electron in on the other side. And then we're going to do your second ionization energy to get into Mg2 plus, giving us a second electron. Then we want to split up our chlorine, so magnesium is still the same. Oh, forgot the state symbol here. We're going to split it apart into 2 chlorine atoms with 2 separate electrons. And then the final change is that those 2 electrons go into those 2 chlorine atoms to go into 2 chloride ions, which is what is equivalent to our lattice enthalpy being split up. So now we've got the transversion values onto our cycle, just to go with what's in the table. Have to be careful, I might have to multiply up or multiply down some values depending on what is actually in my cycle. First one's lattice enthalpy is just written as x kilojoules per mole because we're going to have to calculate it in a second. Enthalpy of formation of magnesium chloride, we're just going to go for minus 642. Again, it's a wee bit of effort, but you probably should put the moles in every time just in case they're going to penalise you for something silly like that. Enthalpy of atomization, simple enough, we're going to have plus 149 kilojoules per mole. First ionization energy, there's no real traps there, plus 736. And no traps with the second ionization energy, plus 1450. Okay, going to be a wee bit careful here, because it's the diatomic stuff's generally the area they can try and trick you here. The change we've got in the cycle is 1 mole of chlorine bonds being broken apart into 2 chlorine atoms. That's the bond association enthalpy. It's double the atomization energy. Remember, atomization is making just 1 mole of the atoms. If you look what they give me in the table, they've given me the atomization energy, 121. I need double that, because I need it for 2 moles of atoms to be produced here. So I'm going to double it to put my value in the table of plus 242 rather than just 121 kilojoules per mole. And the final part of the cycle, electron affinity of chlorine, that's another one to be careful about. That's the energy for 1 mole of chlorine atoms to gain an electron. We've got 2 moles of chlorine atoms, so again I'm going to have to double that one to make it balance out. So it ends up being minus 7 to 8 kilojoules per mole, just doubling 364. So all in all, that does get you 4 marks, so it is a fair bit of credit for being careful of that. And as you notice, once you've done all that, the working out is more or less done for the last part. It's only worth 1 mark for the last enthalpy. You've got all your values in your cycle. Again, remember you would get error carried forward if you did make a wee mistake. So I want to calculate this x value here. I need an alternative route around that cycle. So I'm going to need to flip this arrow to make it plus, and I'm going to change it in the cycle, so that would make that question wrong. It's going to be plus 642, then adding the rest of the values as normal. So plus 642, plus 149, plus 736, plus 1450, plus 242, plus minus 728. In the calculator comes out as being 2491 kilojoules per mole. On to question 8, it's quite a similar question because it's another group 2 compound. It's calcium chloride instead of magnesium chloride. Slightly different style. They've given you most of the Born-Haber cycle and asked you to complete some empty boxes. Obviously it's not worth as many marks, only 2 marks as opposed to 4 in the previous question. So the ones that are missing, we've got our ionic salt here. We're forming it from elements in this part of the cycle, so that's going to be our elements in their standard states. So calcium as a solid, and we'll need 1 mole of chlorine gas. Now if we follow along, we've atomized our calcium, first ionization energy, second ionization energy. We need to split apart our chlorine atoms here, so that's going to be the bond association enthalpy change that's missing. And that completes our cycle. Name enthalpy changes labelled X, have we look here, so that is going from Ca plus to Ca2 plus. That's going to be the second ionization energy. It wouldn't be enough just to say ionization energy, you need to specify which one it is. So with that all done, we now get the calculation question at the bottom. Again, we've been asked to calculate last enthalpy and we've given some values. It doesn't require for this question the working out, but I probably would recommend, like normal, just transferring all these values onto your cycle just to keep you right here. So, the last enthalpy is the one we're trying to work out. If I look down my bottom of my table, the enthalpy of formation is minus 795. The enthalpy of atomization of calcium is plus 190. First ionization energy is plus 590. Second ionization energy is plus 1146. Now this is always a bit, I have to be careful. This is, as we discussed before, is going to be the bond association enthalpy because it's 1 mole of bonds breaking to make 2 moles of atoms. What they've given me is, just check. Yeah, they have given me the bond enthalpy of chlorine, so I don't need to change it. I can just copy across from the table plus 242. However, for the final bit, I think we probably will need to double. This is 2 moles of chlorine atoms to make 2 moles of chloride ions. That's double the electron affinity for 2 moles of it. So they've given me electron affinity of chlorine minus 348. So I need to do 2 times minus 348. So looking at my cycle as a whole, again, I'm trying to find the change from the bottom to top here. I need to go around this route, around the cycle. Just need to flip this arrow to get pointing up. And that will give me the correct numbers. So my final bit of working out is plus 795, plus 190, plus 590, plus 1146, plus 242, plus 2 times minus 348. Type in my calculator, should come out as being plus 2267 kilojoules per mole. Remembering to put the units in. On to question 9, which is a wee bit of a strange one. It's calcium again, so we've seen that before. It's calciumhydride though. Hydrides aren't really something we've looked at so far in chemistry. Essentially it's quite an unusual compound, so the formula you can kind of get from the bond cycle, it's CaH2. If you think about how that must work, the only way you can get that to swap and drop into CaH2, it must be Ca2 plus and 2 H minuses. H minus might seem a wee bit unlikely, but if you think about it, hydrogen itself does just have 1 electron in its outer shell. You're quite used to it losing that electron to form an H plus ion, but it's not inconceivable that it can gain an electron to get 2, and that would also give it a full outer shell. So in some rare situations, you actually can get a negative hydrogen ion when bonded to a positive ion. So we're kind of treating it a bit like chlorine here, like a Cl minus ion. It's no different. So they have given us the full cycle, nothing's filled in there, and they have actually written in the enthalpy changes for us. Part 1 is just a wee bit of kind of AS1 work, write the electronic structures of the calcium and hydride ions. So if I think about calcium itself, it's going to end in 4s2, but I'm losing those 2 4s electrons. So taking those out of the normal calcium structure, we're left with 1s2, 2s2, 2p6, 3s2, 3p6. Again, you always double check in the exam, just count up your electrons and see how it matches up with the electrons from the periodic table. H minus is a wee bit simpler, so obviously hydrogen by itself is just a 1s1. We're gaining an electron to make it negative, it's going to be 1s2. Part 2 says state the value of the HH bond enthalpy. It's kind of maybe a bit of a cryptic question. The only values you got are the ones on the cycle, so basically one of these values is going to lead us to the bond enthalpy of hydrogen. It's going to be this step here. You've got H2 splitting apart into two H's. I guess you're maybe going to be a wee bit wary of maybe they're kind of tricky. Maybe you have to multiply it up or divide it by 2. But if you think about it, that is just 1 mole of hydrogen being broken apart, 1 mole of bonds being broken to make 2 separate atoms. That is just what we describe as the bond enthalpy. So it is just off the table. It's going to be plus 3 or 436 kilojoules per mole. Part 2. If the first ionisation energy of calcium is 590, calculate the second ionisation energy. Now, that in itself seems a very confusing question. What they mean is they've drawn their cycle a little bit strangely. You might notice it's actually missing a step. They've gone straight from calcium as a gas, neutral, into calcium 2+. They've given both ionisation energies all together, which maybe isn't fully correct, but you're allowed to do that. So we know what the first plus second add together is 1740. We know what the first one is, it's 590. So all we have to do to work out what the value of the second one is just subtract those values. So both is 1740. The first one is 590, so I'll subtract it. That should give me the value of the second one, which is 1150 kilojoules per mole. And I expect the second one to be bigger because it's always harder to remove more electrons from a positive ion. Part 4, calculate the standard molar Lattice enthalpy of calcium hydride. So just using your Born-Haber cycle to calculate your values. In this case, it's not that tricky because all the values have been actually written on for you. So it's just following your cycle. So remember, going from here to here, you just need to go around this side of the cycle, which involves flipping this arrow to make all the arrows point the correct direction. I'm going to flip its sign as well. So it gives me the final working out of plus 189, plus 193, plus 1740, both ionisation energies together, plus 436, plus minus 144. In the calculator goes, it comes out as being plus 2414 kilojoules per mole.